This is section 5.4, and we're looking at special right triangles. And in this section, our learning goal is that students will understand how to calculate the side lengths of special right triangles. And the 3 success criteria we have for this section is to be able to find the legs or the hypotenuse of a 45-45-90 triangle, to be able to find the legs or the hypotenuse of a 30-60-90 triangle, and then to use those properties of those particular special right triangles to help us find the area or maybe even the perimeter of a figure. So let's begin. Oops. Okay, there's 2 types of special right triangles, and we call them special because they pop up over and over and over again in lots of different types of mathematics. Like I said in class, it's really helpful to know how to work with these for any kind of standardized testing, including AIMS or SAT or ACT classes or something like that. But this is also important for trigonometry, calculus, and other applications in mathematics. Okay, so there's 2 types of special right triangles. There's what we call 45-45-90 triangles and 30-60-90 triangles. And of course, those values that you see here are referring to the angles that you see in the triangles. So let's look at those 2 types of triangles. Okay, in the 45-45-90 triangle, which you see here, we call that an isosceles right triangle. It's isosceles because both of the angles are 45 degrees, which are both of the angles that aren't 90 or 45 degrees. So that means that these 2 angles here are each 45 degrees, and since we have congruent angles, then we must have congruent sides across from those angles. So for example, this side would be congruent to that side. This angle here is obviously the 90-degree angle. So we have 2 congruent sides and 2 congruent angles. In a 30-60-90 triangle, the ratios of the angles are in a ratio of 1 to 2 to 3. And we need to know 2 out of the 3 angles to be able to know that it's a 30-60-90 triangle. For example, if we knew this was 90 and we knew this angle was 30, we could subtract from 180 to conclude that the angle at the top here was 60. In another example, let's say I knew this angle here was 30 and I knew this angle down here was 60. I could add those together and again subtract from 180 to conclude that this was a 90-degree angle. Okay, with the 45-45-90 triangle, sometimes it's enough to know that this is a 90-degree angle and that these 2 sides are congruent. If those 2 sides were congruent, then the angles across from them must be congruent, and they must each be 45 so that all the angles add up to 180. All right, let's do a couple examples and talk about the properties we need to know. With a 45-45-90 triangle, the 2 congruent sides are called the legs, just like they are in any right triangle. And of course, the side across from the 90-degree is the hypotenuse, right? Hypotenuse here, always across from the 90. Now here's the relationship that you need to know. The 2 legs are kind of the most critical pieces of information because they're the 2 congruent sides. If I know one of these legs, I can find the other leg because they're the same, and I can find the hypotenuse by multiplying by the square root of 2. So for example, if this side over here is x, the other leg will also be x, and then the hypotenuse will be x times the square root of 2. So, I actually should change this a little bit. This isn't quite right. Let's delete that. This should read that the hypotenuse, let's fix that real quick. The hypotenuse is equal to the leg times the square root of 2. And this is a really important formula. This is something that you should highlight in your notes. It's the type of thing that you would get as a formula on an exam or standardized test, although sometimes that formula might be in the form of a diagram like we see here. So let's do an example. Let's solve for x and y. Now right off the bat, we see we have a 90-degree in my triangle. We see this angle here is 45, so we know that this angle has to also be 45. Okay, now because it is a isosceles right triangle, the two legs must be congruent. Therefore, x has to equal 5. Y is the hypotenuse. And remember we said that the hypotenuse is equal to the leg times the square root of 2. So in this case, the hypotenuse, y, has to be equal to the leg, which was 5, times the square root of 2. So we just would say y equals 5 root 2. And that's it. All right, let's do one that's a little harder. Let's solve for x and y in these examples. Here in the first one, again, we see that the triangle is isosceles and it's 90 degrees, so we know that the triangle has to be a 45, 45, 90 triangle. Oops, sorry about that. We see that the hypotenuse is equal to 4 root 2. I also know that the hypotenuse is equal to whatever the leg is times the square root of 2. So let's plug in the information I know and the information I want. The hypotenuse here is 4 times the square root of 2. And that is equal to the leg that I want, x, times the square root of 2. So if I'm going to solve this, I have multiplication, x times the square root of 2. So to undo that multiplication, we divide both sides by the square root of 2. Root 2 divided by root 2 is 1, and the same happens over here. Root 2 divided by root 2 is 1, and so we can see that all that's left is 4. So x is 4. Now go back up to my picture. If x is 4, y is also 4 because it's an isosceles right triangle. Let's look at the next example. It's a little bit more complicated because the hypotenuse here is just 8 and not 8 times the square root of 2. So this actually works a little bit differently here. So let's plug in our formula, or let's write down our formula again. Hypotenuse equals leg times square root of 2. Plug in what we know. We know the hypotenuse is 8, and one of the legs that I don't know is x, and then we have times root 2. Again, to undo that multiplication, we're going to divide both sides by the square root of 2. Now over here on the right, root 2 divided by root 2 is just 1, so all that's left on the right is x. But over here on the left, we have 8 divided by the square root of 2. Now we're going to have to use a process that's called rationalizing. In mathematics, we usually don't want to leave square roots in the denominator of our answer. So since I'm dividing by the square root of 2, root 2 is in the denominator, I'm going to use a technique where I multiply on top and bottom by that same square root. So I'm multiplying by root 2 over root 2. See right here? Root 2 divided by root 2 is equal to 1. So I'm not really multiplying by anything that's going to change the value. I'm just multiplying by a special form of 1. Now watch what happens when I do that. On the top, 8 times root 2 is 8 root 2. On the bottom, root 2 times root 2 is the square root of 4, but the square root of 4 is 2. So now I don't have a root down there anymore. Now we can divide. 2 goes into 8 4 times. So x is going to simplify to 4 root 2. And again, since x is equal to 4 root 2, and this is an isosceles right triangle, y is also going to be equal to 4 root 2. Okay, so let's go over the rules for 30, 60, 90 triangles. In a 30, 60, 90 triangle, all the side lengths are different. The one that's the most important is the shortest leg, the side that's attached to the 90 degrees that's the shortest. The shortest leg is always across from the smallest angle, which is 30 degrees. So we call this side the short leg. Sometimes I abbreviate that with SL. The side that's across from the 60 is the long leg. Sometimes I use LL. And of course, the side that's across from the 90 is the hypotenuse, either h or hyp, something like that. Okay, so the relationship that we see here, if the short leg is x, then the long leg is going to be whatever the short leg was times the square root of 3. The hypotenuse is going to be twice as big as the long leg. Okay, now we can see that in a formula written here. The hypotenuse is 2 times whatever the short leg was, and the long leg is the square root of 3 times whatever the short leg was. All right, so let's do an example. Let's say we know the short leg. Those are always the easiest types of problems because everything else is based off of the short leg. So remember, the long leg was the short leg times the square root of 3. So if I wanted to find the long leg here, the long leg is across from the 60, which has to be up here. So this side has to be the long leg. So the long leg is y, and it's going to equal the short leg, which was 7, times the square root of 3. Or we would just write y equals 7 root 3. The hypotenuse is the short leg times 2. So maybe let's write that down here. Or is 2 times the short leg. The hypotenuse is here across from the 90, so that's x. So that's going to be 2 times 7, which is 14. And that's it. Okay, let's do another one. Let's say in this case we don't know the short leg, but we know instead the hypotenuse. That one's not too bad as well. But again, the first thing I want you to do is label the sides of your triangle. Since my 60 is over here, this side has to be 30. So the side across from the 30 is my short leg. The side across from the 60 is my long leg. When you know the hypotenuse, the first step that you want to do is find the short leg. Okay? Because the long leg is going to be dependent on how big the short leg is. So let's write down the rule. The hypotenuse is equal to 2 times the short leg. Plug in what we know. The hypotenuse is 6, and the short leg is x. So 6 equals 2x. To solve that for x, we would divide both sides by 2, and we would get x is equal to 3. So I'll put that in my diagram. Then to find the long leg, again, start with your equation. The long leg is equal to the short leg times the square root of 3. So y is equal to the short leg, which was 3, times the square root of 3, or we would just write y equals 3 root 3. And we're good. Okay, so last we're going to do a type of problem where we know the long leg. And I've got two different examples here. The first one's pretty easy. The second one is more difficult because we have to do some crazy things with the radicals. Okay, so let's label my triangle first. My 30 degree is here. So my 60 is up here. So across from the 60 is my long leg. Across from the 30 is my short leg. Across from the 90 is my hypotenuse. Again, you still must find the short leg first. So write down your formula. Long leg is short leg times the square root of 3. Plug in the information you know. 5 root 3 is equal to the short leg, which was x, times the square root of 3. To undo multiplication, we divide. So we're going to divide by root 3 again. And this is why this problem is not so bad, because when I divide by root 3, it kind of goes away on both sides. So x is equal to 5. So my short leg is 5. Now we're going to find the hypotenuse. What's the rule? The hypotenuse is equal to 2 times the short leg. In this case, my hypotenuse is y. My short leg was 5, so 2 times 5. So y is going to equal 10. And we've got x. We've got y. We're done with that one. Now let's do one that's a little bit more complicated. The process is going to be the same. Start with your formula. Long leg is equal to the short leg times the square root of 3. Here's my 60. Again, 6 is the long leg, and x is the short leg across from the 30. So we want to find x first. Plug in what we know. 6 is equal to x times the square root of 3. Just like the other problem, we're going to start by dividing both sides by the square root of 3 to get x by itself. So now we have x is equal to 6 divided by the square root of 3. But we can't just divide 3 into 6 because the 3 is really square root 3. So we do the same thing we did before, and we rationalize this. In other words, we multiply the top and bottom by the square root of 3. Again, we're really just multiplying by 1, so we're not changing its value. On the top, 6 times root 3 is 6 root 3. On the bottom, root 3 times root 3 is the square root of 9, but the square root of 9 is 3. And then you want to check to see if you can reduce. And you can see that 6 is divisible by 3. 6 divided by 3 is 2. So we get 2 root 3 for x. So I'll put that in my diagram. Now we can do the hypotenuse. The hypotenuse is equal to twice the short leg. So write our formula, 2 times the short leg. The hypotenuse here was y, and the short leg was 2 root 3. So what is 2 times 2 root 3? Multiply the like parts together. 2 times 2 is 4. So y is equal to 4 times the square root of 3. Or the hypotenuse is 4 root 3. Great. Okay, so that's it for the work we're going to do with special right triangles and the formulas. In class, we'll be applying those formulas to finding the areas of some figures where you need to find some unknown parts before you can find the area. Okay, do the practice examples along with those problems, and we'll work on some more of these types of questions in class.